Welcome to our YouTube channel. In the previous video of feature encoding in Python of the Data Science and Machine Learning series, we got to know the definition and importance of feature encoding in Python. We also discussed label encoding in depth. In this video, we will be covering the second part of feature encoding, which is One Hot Encoding. Before we move ahead, let us have a quick recap of the previous video. In the previous video, we saw what is feature encoding. We saw that while working with a data set, we come across various variables associated with it. They can be numeric or categorical. Then we stressed upon categorical variables through an example, that is gender can be categorized into male or female. But then we came to know that computers can only understand numbers. So while working with a machine learning algorithm, we need to convert every categorical variable to a numerical value associated with it so that our algorithm will be able to understand it. Then we looked at the meaning of label encoding. Let us revisit it with an example. Here we have a color table wherein each color, that is each categorical variable, is given a numerical value associated with it. This is what is essentially done in label encoding. Now let us move ahead with One Hot Encoding. But before we go ahead, I would like to ask you a question. Could you possibly think of one reason why label encoding is not that efficient for training our model? What makes One Hot Encoding better than label encoding? Pause this video here and give it a thought. Now, I hope that you have thought about it. Let us discuss why is One Hot Encoding given an upper hand over label encoding. The problem with label encoding is that it correlates numerical value with weight given to that category. That is, it works on a principle that is higher the categorical value, better the category. What happens because of this is that a priority level is developed within an existing category, and it kind of makes our model biased towards that category which has higher numerical value associated with the variable. Let us understand this better with the color example that we saw previously. Now suppose we feed in red color to this model, it might result into predicting it as blue. Now why does this happen? This happens because blue is associated with the number 2, which is higher than 0 with which red is associated. So our model kind of inclines towards blue while it makes predictions biased to that categorical variable which has higher integer value associated to it. Now what does One Hot Encoding do? One Hot Encoding is basically a process in which categorical variables are converted into a form that could be provided to a machine learning algorithm to do a better job in prediction. What better job does it do? Let us see. It essentially splits the column which contains numerical categorical data to many columns depending on the number of categories present in the column. Each column is then binarized, that is converted to zeros and ones, and in this manner the bias is eliminated. Now let us go through an example to understand it even better. Here we have 5 car companies: Audi, BMW, Honda, Ferrari and Ford. If we label encode this data, then we get 0, 1, 2, 3 and 4 as the numerical values associated with each variable. But if we use One Hot Encoding here, we get this table. That is, with Audi we have 1, 0, 0, 0, 0 as the binarized value. For BMW we have 0, 1, 0, 0, 0 and so on so forth. Now we will try and implement this on a code. So let us get going. In the very initial step, we will be importing NumPy and Pandas as NP and PD respectively. Then we'll be creating a dummy data frame. Here I have a data frame in which the first column is the ID starting from 1 to 9. And then the second column is of the name where there are 9 names, followed by the third column which is car names. So let us display that. Yeah, right. So now you can notice in the car column we have 5 categorical variables of different companies of cars, which are written down here, that is Audi, BMW, Honda, Ferrari and Ford. Now we'll be applying one hot encoder to convert categorical variables into binarized form. So from sklearn.preprocessing we'll be importing the class one hot encoder, and then we will be creating object of this class, and we will be creating a data frame for the same. So now if you're not able to visualize how this will look like, let us print that. You can see for each categorical variable you have a binarized format for all 9 names respectively. Now let us concatenate it to our pre-existing data set. So let us see how it happens. Now you can see we have the predetermined columns ID, name and car, and we have concatenated it. Concatenated the 4 other columns, 5 other columns to it. So what exactly happened here was, for the names, for the car names which were against Audi, it got binarized to 1, and the 0 column got binarized to 1, and all the other 4 to 0 represented Audi, the categorical variable Audi. Similar goes with BMW, Honda, Ferrari and Ford. Respectively, they are binarized with different numbers associated with them. Now to make the data clear to visualize, we'll be dropping the car column so that it becomes easy to understand. And then we will be renaming the 0, 1, 2, 3, 4 columns to the respective car names, so that we'll be able to differentiate. And then we'll be printing the final data. So yeah, that's all. Now you can see that we have successfully implemented one hot encoding in this dummy data frame that we created.